So we are passing on to the third unit of environmental biology, and it includes biogeochemical cycles. The biogeochemical cycles, the different types, its importance in the ecosystem. So this unit includes the basic types of biogeochemical cycles, the two types of cycles, gaseous cycle and sedimentary cycle. And you'll be learning about carbon cycle and nitrogen cycle under gaseous cycle, and the two types of sedimentary cycles as well. Okay. So biogeochemical cycles. Biogeochemical cycle, the concept was introduced by Wernadsky in 1934. Actually, why biogeochemical cycles, or what is biogeochemical cycles? Um, Actually, what is biogeochemical cycles? The name says something, isn't it? It is the cycling of chemicals between biological world and geological world, right? So, uh, what is a chemical actually here referring to? They are the chemical elements which are required for the normal growth and development of the organisms. Okay, there are about 40 chemical elements that are required for the normal growth and development, and most important among them are carbon, nitrogen, hydrogen, oxygen, potassium, calcium, magnesium, phosphorus, and sulfur. Okay, these are required by plants as well as animals. That doesn't mean that there are no other chemical elements required by the organisms. There are, but they are not required in a huge amount. They are required only in trace amounts, but are very essential for the various activities going on in the organisms. Okay. Now, how can we define biogeochemical cycles? It is actually, it can be defined as the cyclic path of the chemical element uh, from the abiotic system to the biotic system and back to the abiotic system is, can be called as a biogeochemical cycle. Okay. It is a cyclic movement of chemical elements of the biosphere between the organism and the environment. And as these elements are the chemical elements we are referring to, as actually they are essential to life as elements of food, these cycles are also termed as nutrient cycles. Okay. Now, what are the different phases of biogeochemical cycle? The biogeochemical cycle has two phases. So every cycle has two phases. Okay. So it is biotic phase and abiotic phase. Biotic phase is otherwise known as the organic phase. Now, why the name biotic? Because it includes the um, pathway taken by the chemical element uh, involving the organisms. Okay, it is actually biotic phase involves flow of the chemical element along the organisms in a food chain. Right. For example, if you're speaking about carbon cycle, what happens in carbon cycle here is in carbon cycle the major reservoir, the main reservoir, or where the carbon is found, it is atmosphere. So it is in gaseous form. This gaseous carbon dioxide is taken by um, the producers or the green plants, and what they do is they fix carbon by the process of photosynthesis and convert the carbon dioxide into carbohydrates or the organic matter. Okay, the plants are then consumed by the consumers. Now you can see carbon is actually an abiotic phase. The carbon in the air is an abiotic phase. So the air is actually an abiotic component of the ecosystem. When this carbon gets fixed as an organic matter, it becomes a part of the living what you call biotic component. It is the producers. And then when it is eaten by the consumers, again it is passing from one biotic component to the other. So the first part, that is carbon in the air, is an abiotic phase, right? That is, it is outside the food chain. Once it enters the process of photosynthesis, it is a part of the plant, and that is actually a component in the organic phase or biotic phase. I hope that is clear. Okay. Now, abiotic phase can be of two classes. One is sedimentary phase or atmospheric phase. Um, Depending upon the abiotic phase, that is a sedimentary phase or atmospheric phase, we can have two kinds of biogeochemical cycles. If it is a sedimentary phase, if the biogeochemical cycle includes a sedimentary phase as the abiotic phase, such biogeochemical cycles are called as sedimentary cycles. Right? If it is the atmospheric phase as the abiotic phase of a biogeochemical cycle, that kind of cycle is referred as gaseous cycle. I hope it is clear. Okay, so there are two classes of abiotic phases. Now, sedimentary phase is where the flow of elements outside the food chain, that is abiotic phase, isn't it? In sedimentary phase, this flow takes place through soil or the rocks, right? Sedimented forms on the earth. Now, in atmospheric phase, this flow of elements is in the gaseous. So that is why it is known as atmospheric phase. Now, as we said, depending upon the kind of abiotic phase, you can identify two types of biogeochemical cycles, that is a gaseous cycle and sedimentary cycle. The main reservoir of elements in gaseous cycle is the atmosphere or oceans. Okay, examples like carbon cycle, nitrogen cycle, and oxygen cycle. While in sedimentary cycle, the main reservoir of nutrients is the soil or rocks. Okay, it is sedimentary and other types of rocks in the Earth's crust. So it can be on the land or in the water. It can be anywhere. So that's the sedimentary cycle. And the best example for sedimentary cycle is sulfur cycle and phosphorus cycle. I hope it is clear, right? Now, in the nitrogen cycle, it has been included in the gaseous cycle because atmospheric phase is the most important one, or it is the most predominant one, right? But in the phosphorus cycle, it is the other way around. In the case of phosphorus cycle, it is actually sedimentary phase which is more important. So what happens? It is included under sedimentary cycle. Okay. Now we'll just go through carbon cycle. Carbon cycle, the major processes by which, the main reservoir of carbon cycle is obviously gaseous carbon dioxide in air. That is a major reservoir. Okay, and that is why it has been included under gaseous cycle, right? So the processes by which carbon dioxide is taken out from the reservoir, there are two processes. One, where carbon dioxide is taken up by the plants by the process of photosynthesis. So it is getting fixed in the biotic phase, right? The second the second way by which carbon dioxide is taken out is actually the gaseous carbon dioxide in the atmosphere get dissolved in water. Okay, that is dissolved carbon dioxide in usually in seas and oceans, right? There, what happens is this dissolved carbon dioxide is then used by shelled animals like crustaceans, mollusks, etc. Right, and they use this for the production of calcium carbonate. Actually, this is what is used for production of shells, and this is actually removing of the carbon dioxide from the reservoir. Is it okay? Right. Now there are plenty of ways by which the carbon dioxide is put back into the reservoir. The most important one is respiration in plants and animals. Right. During respiration, carbon dioxide in gaseous form is released out into the air or into the water. Right. Second way is decomposition. During decomposition of dead plants and animals, the carbon dioxide is released out. That is, organic matter of the dead and decaying plants and animals is broken down and carbon dioxide is released. Fermentation, I didn't tell you, it is anaerobic respiration. Where also carbon dioxide is released. Weathering, actually it is breakdown of the rocks and the formation of soil, isn't it? During weathering, carbon dioxide trapped inside it is released into the air. Then, fossil fuel combustion. Okay, so fossil fuels, they are formed from decomposing plant and animal, which are kept under pressure for a long period of time, isn't it? Petroleum products, fossil fuels, isn't it? So these fossil fuels, it contains the organic matter, right? And then when this is burnt, what happens is the carbon dioxide trapped is released. So that is another way by which the carbon dioxide reach back into the So this is a flow chart which represents the what you call carbon cycle. Whatever we have discussed in the last slide, you can see over here. So starting from this is another important gaseous cycle in the ecosystem, the nitrogen cycle. Why is nitrogen so important? Actually, nitrogen is an essential constituent of amino acids and proteins, and you know that proteins are building blocks in the living world. So the main reservoir of nitrogen is air, okay, and it is atmospheric nitrogen, molecular nitrogen. You have already studied in your chemistry thesis that molecular nitrogen it exists in N2 form, and it is N triple bond N. It's almost like a stable compound. And even though all the organisms, including plants and animals, require nitrogen, but they cannot use the atmospheric nitrogen, which is available in plenty in the atmosphere. You know that almost 78% of the atmosphere is nitrogen. But still, these plants and animals cannot use the atmospheric nitrogen. Animals can use nitrogen only in the form of amino acids and proteins. So where do they get amino acids and proteins? They depend upon plants for that source, right? And what about plants? Plants can use nitrogen only in the form of nitrates and insoluble form. Okay, it's not insoluble. Nitrates are soluble, right? Only the soluble nitrates can be taken by the plants. Sorry. So, um, nitrogen in the atmosphere has to be converted to nitrate so that it can be taken up by the plants. And from the plants, these nitrates can be used for the synthesis of amino acids and proteins and can be stored in their body. Now, when the animals consume these, the protein reach their body. Right? During the process of digestion in the animals, it is broken down into amino acids or chain of amino acids, and these amino acids can then be absorbed into the body, can be used for the synthesis of proteins the animals require. Okay, so that is how the whole sequence goes. But who can convert this nitrogen into the nitrate, which is required by the plants? So that is what happens in the nitrogen cycle. The first step in the whole process is nitrogen fixation. Nitrogen fixation is actually the process of conversion of nitrogen into nitrate. Okay, nitrogen fixation. Right. Nitrogen fixation during nitrogen fixation, actually, molecular nitrogen, that is N2, it splits into two nitrogen atoms, and then it combines with hydrogen to form the ammonia. Uh, but it is not an easy step. The first step, the whole process of nitrogen cycle involves conversion of this one into ammonia. Right. The first step is the nitrogen fixation. Right. The nitrogen during the nitrogen fixation, nitrogen is getting converted into nitrates. Right. The fixation of nitrogen takes place by way of two methods. One is physicochemical method, and the other is biological method. The physicochemical method is otherwise the high energy fixation process. It actually occurs by way of lightning and cosmic radiation. So during lightning, what happens is high amount of energy passes through the atmosphere, and this bring about the breaking of nitrogen. And this nitrogen combines with oxygen and hydrogen of water separately. So when nitrogen combines with oxygen, it forms nitrogen oxides. Right? When nitrogen combines with hydrogen, it forms ammonia. So that is how high energy fixation occurs. But biological fixation contributes to almost 90% of nitrogen fixation occurring in the earth. Now, this biological nitrogen fixation includes the what you call nitrogen fixing organisms, right? And mainly they are bacteria and blue-green algae, cyanobacteria, right? So, biological nitrogen fixation takes place by way of um, two groups of organisms. One is you already know symbiotic nitrogen fixation or symbiotic nitrogen fixers. What is that? It is the bacterium rhizobium which resides in the um, root nodules of the legumes. So it is symbiotic association. That is rhizobium and the leguminous plants, they are mutually benefited because of this kind of an association, right? So here the rhizobium in symbiotic association can help in nitrogen fixation. Now, second is um, free living nitrogen fixers. That is those nitrogen fixing organisms which resides freely in water or soil. And you can see that the free living nitrogen fixers in soil usually they are bacteria, and in water they are usually blue green algae. So the free living soil residing nitrogen fixers include azotobacter and clostridium, while free living nitrogen fixers in water, that is blue green algae. Have I gone wrong? Okay, just 1 minute. Free living nitrogen fixers in soil includes bacteria, and the examples are azotobacter and clostridium. And free living nitrogen fixers in water are blue green algae. Examples you have already studied in your botany classes, nostoc and anabina. So I hope it is clear. So nitrogen fixation, right? So here nitrogen is getting fixed in the form of nitrogen, right? Now another source of nitrogen. So it is not that the atmospheric nitrogen is the sole source of nitrogen, but there is yet another source of nitrogen on the earth, and that is a dead organic matter. We already saw that the plant and animal body is composed of nitrogen, or organic matter that is composed of nitrogen. So when they die, the dead decomposing body of plants and animals are rich in nitrogen rich compounds or nitrogenous compounds. So certain bacteria they break down these nitrogen compounds found in the tissues of plants and animals during the process of decomposition. And the whole process takes place in two stages. The first stage is known as ammonification. Here, the decomposing organic matter is converted to ammonia, right? And these bacteria, which is involved in this conversion, is known as ammonifying bacteria. Bacillus is one example of ammonifying bacteria. Now, in the second step, what happens is uh, it is known as nitrification, and here the ammonia produced in the first step is getting converted into nitrate. Okay, it is not a single step; it occurs in two steps because uh, ammonia has to get converted into nitrite, and then only it can be converted into nitrate. And these two steps, that is ammonia to nitrite and then to nitrate, these two steps cannot be um, like done by the same set of bacteria, right? So first step here, what happens? Ammonia has to be converted into nitrite, and this is done with the help of soil residing nitrosomonas and nitroso, nitrosomonas and nitrosococcus, right? The second step where the nitrite formed is getting converted into nitrate, right? And this is done by nitrosocystis and nitrobacter bacteria. Okay. And once this is completed, nitrate is formed and it is fixed in the soil. The nitrate is freely dissolvable, and hence it gets dissolved in soil water. So, along with water, this soluble nitrate is taken up by the plants, and it utilizes for the synthesis of the body to the growth and development, and it is being stored in the body as proteins. Okay, but what happens is in certain situations, these nitrates, before it is being taken up by the plants, it gets acted upon by denitrifying bacteria. Okay, and that process of conversion of the nitrate to free nitrogen or ammonia with the help of denitrifying bacteria, it is known as denitrification. I hope it is clear. In some case situations, what happens before the nitrate is taken up by the plants, it may get converted into ammonia or free nitrogen. Free nitrogen in the sense atmospheric nitrogen, gaseous nitrogen. Okay, and this process is known as denitrification, and this releases the nitrogen back into the atmosphere. And this happens by way of bacteria like pseudomonas. I hope it is clear, right? So that is regarding the nitrogen cycle. And the figure, I hope it is clear to you. The first, okay, and learn the content thoroughly. Now sedimentary cycles under biogeochemical cycle is pending, and it will be dealt in the coming presentation.